So we're going to be talking about the embryology of the heart. And we're going to break it down very simply so that you understand everything that's going on. I've drawn a lot of crap up here. Don't let it confuse you. Don't even look at it yet. We'll go through it step by step, and you should be, by the end of it, understand what's going on. Okay, so let's just begin at the beginning. The first thing that happens is the egg is fertilized. It moves down the uterine tubes, and you'll get something looking like this. That's called the blastula. That's what you were before you were born, before anything happened. So as the blastula migrates down into the uterus, it implants into the uterine wall, and a process of gastrulation will form the 3 germ layers. And I'm sure that you've seen this everywhere. It's a simplification of what we see here. So we have, there's the top layer in blue, that's the ectoderm. The ectoderm gives rise to the epidermis and the central nervous system. In the middle we have the intermediate mesoderm, and at the bottom in green we have the endoderm. So the intermediate mesoderm has 3 main components to it. First, it has the paraxial mesoderm. The paraxial mesoderm gives rise to the somites, so you'll have your muscles developing from the paraxial mesoderm. You'll have the intermediate mesoderm. And the intermediate mesoderm gives rise to the gonads and the kidneys. And finally, we have the lateral plates at the end. So the lateral plates are made up of 2 different plates. We have the somatic and we have the splanchnic. Now the heart is derived from the splanchnic lateral plate, so the splanchnic mesoderm. So the first thing that you should know is that the heart, where is it derived from? From the mesoderm, from the lateral plates, from the splanchnic mesoderm. So the progenitor heart cells, they actually migrate from the epiderm, from the ectoderm, cells from the ectoderm, and they migrate down the primitive streak into the splanchnic mesoderm. So as they are migrating, they'll live where the splanchnic mesoderm is. And this section now will be called the primary heart field. Now the primary heart field gives rise to the left ventricle, the atria, and part of the right ventricle. So where does the rest of the right ventricle come from? It comes from a section called the secondary heart field. Now, if we have just give me your attention just to this over here. Don't look at anything else, just look at here. And it might be a bit difficult to understand, but we'll go through it. So what happens is the rest of the right ventricle comes from here. So you have this section here where the secondary heart field is, and in red here we have the heart. So we have the primary heart field made from the cardiac myoblasts and the blood islands that were from the splanchnic mesoderm, making up the heart over here, which we'll go through in a second. And the rest of the heart is derived from the secondary heart field over here, which is still from the splanchnic mesoderm. So this here is still from this section over here. Okay? So what happens is it sends cells down and it builds and elongates the heart, and it is responsible for building up the truncus arteriosus and the conus cordis. So that's just, and it's important to know this because any shortages, any defects in the secondary heart field would lead to defects in childbirth. So with that being said, let's move on to how the heart is actually developed. So this Pokemon looking creature over here is a day 18 cross section of the embryo. So it's got this big green tongue, that's still the endoderm, and as it folds, if we just pay attention to the green's the endoderm, it has nothing to do with the heart, but just to get an idea of what's going on, it'll form the primitive tube over here, primitive gut tube. So this green endoderm, Pokemon tongue, becomes Pokemon mouth into the primitive gut tube right over here. So let's pay attention to the Pokemon's face now. So its cheeks and its eyes. The whole Pokemon over here in red is still the splanchnic mesodome. It's still this bottom section of lateral plate. So what happens is as it folds, the blood islands and the cardiac myoblasts will form these endothelial heart tubes. And these dorsal aortae. And to get an idea on what that is, how that actually looks like, because this probably still looks like a Pokemon to you, you don't know how the heart is derived from that, just let's flip this up like this, just like, whoosh, and then you'll have something like this over here. So you have your endothelial tubes here, and I'm sure you've been exposed to that before, you've seen what that is. So you have your venous blood coming in and going up. And what happens as the embryo folds both dorsally and cranially, it also folds laterally, and that will cause the endothelial tubes to join. So these are the endothelial tubes. This is a flipped up version. And so what happens is that it fuses into one over here on day 22. And likewise, the dorsal aorta, they will fuse and become the descending aorta. So, the cheeks of the Pokemon, they're the endothelial tubes. Don't get too confused about it. It's just this. So this is this, and that is that. So blood flow is coming up. And that would be eventually the descending aorta over here. So, looking at this Pokemon that has transformed into whatever it is now with the mouth, you have over here the single cardiac tube, the heart tube, which can be which is equivalent to this or this. So if we flip this up again, you'll see either this or this. So and these obviously are the dorsal aorta, which will eventually fuse together, and this is no longer an endothelial tube. You can say that it's the heart now. So the heart has begun pumping. And so on day 22, so we should probably go through this the anatomy of each section. So the bottom over here will have the atrium, and we will also have the sinus venosum. So the sinus venosum gives rise to the smooth wall layer of the atrium. The atrium gives rise to the left and right atrium. And this big bowl section, that is the ventricle. And that gives rise to the left ventricle. And then we'll have the bulbous cordus. And also the truncus arteriosus. So we still have the atrium here, maybe in this section, the ventricle here, the bulbous cordus, and the truncus arteriosus. And essentially, how the heart folds is that the bulbous cordus and the truncus arteriosus, they fold ventrally and dorsally, and the ventricle, atrium, and the sinus venosum are squished up behind it. So you'll have this, if we look at it from a little bit of a side view, a squishing up happening, if I can explain it in that simple way. So the truncus arteriosus and the bulbous cordus fold ventrally and dorsally, so forward and down, and squish up the rest of them. So, and by day 24, we'll have the heart looking like this. And at day 28, if we get the frontal section, it'll look like this. So you have blood flow leaving the heart from here and receiving it from the back. So this over here is behind this heart right now. So on day 30, if we just slice the heart like this, on day 30 we'll have a heart looking like something like this. And I'm not going to go into too much detail. I'm just going to discuss the blood flow in it and essentially how it develops. So we'll have the blood flow coming in like this. So it comes in here from the atrioventricular section and flows in from out through the truncus arteriosus here. So eventually, as the heart develops, the septum will form, and this will go into two parts like this. Okay? That's out of the... We'll discuss the development of each septum in a different video. But essentially what happens is, right before birth, the heart will look like this. But not really. I'm going to go through the development of the Foramen Ovale as well, to finish it off. So, what happens is, we have a bud growing from the top of the heart called the septum primum, and also from this endothelial cushion we have a bud growing, and eventually they grow in a way so that they meet each other and form completely. But before they form completely, cell death causes the top part to open up like this, and at the same time we'll have a septum secundum growing from the top and from the bottom. So the gap that the septum secundum leaves, so that's the septum secundum, and this is the septum primum. So the gap that the septum secundum leaves, that's the foramen ovale. So just here, this section is the foramen ovale. And it's very important to understand this because defects in this can contribute to tetralogies of the heart, such as the tetralogy of Fallot. For example, that's the disruption in the foramen ovale is one component of that. So what happens is, before birth, the pressure in the right atrium is much higher than the pressure in the left atrium. So what that causes is blood flow to be pushed from here into here. So this septum primum can act like a valve, and the purpose of that is to bypass the pulmonary circulation. So at birth, however, what you'll have is a pressure change where there's increased pressure in the left atrium. So what that causes is a closure of this valve, and eventually, with increasing pressure in here more so than here, the septum primum and the septum secundum will fuse and permanently shut. So that's how the foramen ovale is closed, and that's a general overview of how the heart is developed. If you have any questions, please leave a comment under the video. Thanks.